So you probably graphed a circle in its standard form. So you might want to actually relate graphing the ellipse to a circle. The procedures are similar, but they're also different. So the standard form of a circle has a center called HK. And remember that the radius is represented by r, and it's going to be r squared in the equation, and r is greater than 0. So that is the standard form of graphing a circle, centered at HK. Remember, the center is more of a location of the circle. It's not part of the graph, but we need to locate, right? We need to have a center in our circle. It's very similar in ellipse. We're also going to need a location for our ellipse. It's kind of like when you look on the GPS of your phone, you see that little dot that shows your location. So think of the center as that little blue dot on your phone, or the one I'm talking about in Google Maps, for instance. I'm going to first give you the standard form of an ellipse, and it turns out there's two of them. So x minus h squared plus y minus k quantity squared over a b squared, a squared is equal to 1. So this is a standard form of an ellipse where a is always greater than b and b is always greater than 0. So we could look at one of the standard forms as that. So the a is always greater than b, and that's going to actually help you locate something called the major axis. So if you think about ellipse is like a fancy word for ovals. The long side of an ellipse has a name. We actually call that and that side right there to be the major axis. And this is going to be related to the letter A. Whether they're located vertically or horizontally, we're going to be able to find out by graphing this ellipse. So you may have graphed circles with ordered pairs, but for ellipses, you definitely don't want to have to choose ordered pairs to graph an ellipse. We're going to do a shortcut instead. What would that shortcut look like? Let's see. The first thing you do, of course, is if you have graph paper, you want to take advantage of it. I don't have graph paper with me, but I'm pretty good at drawing my own. So, be neat if you need to. If you don't have graph paper, you could download it from the internet, print some out, or, you simply draw your own and be very, very neat about it. The first thing we want to do is actually identify your center. Our center is what? It's going to be HK, which equals 2, comma, negative 1. And our A is going to be 3. Our A is 3. And our B is 2, right? So be able to locate all your numbers. First thing you want to do is plot the center. The center is 2, negative 1. And 2, negative 1. 2, negative 1. I'll go ahead and use blue, kind of like that blue dot on your GPS of your phone. So 2, negative 1. There's our location. And now we're going to use the A's and B's. I'm going to first go B, right? Usually when you plot ordered pairs, you like to do your X values first. So I'm going to go 2 units to the right from that star. I'm going to go 2 units from the right. Oops. 2 units from the right. And I'm going to plot a dot here. And I'm going to go 2 units to the left and plot a dot as well. And that is going to be the endpoints of what we call the minor axis. So it doesn't hurt to label those. It's really nice to label them like that as an ordered pair, right? And so you have negative 1 and negative 1 here. Location, location, location. All right. Now, we look at the A value, which is under the Y. So if you look at the A value is 3. So from that blue star, we're going to go vertically 3 units and vertically down 3 units and plot another ordered pair. 1, 2, 3. And then down 1, 2, 3. And of course, label those ordered pairs as well. 1, comma 2. And then what do we have here? We have 1, comma, negative 4. Notice those are the endpoints of your major axis. Let's connect our dots to make an elliptical orbit. So not a total surprise. Ellipses are definitely studied in astronomy. A lot of our planets and moons travel in elliptical orbits. And if they don't travel in elliptical orbits, sometimes they travel in hyperbolic orbits. And we'll get to hyperbolics or hyperbolas very soon. So there's your ellipse. There you go. Oh, let's highlight the major axis here. You don't have to do this, but I just want to let you know this is the long way. And notice the long way here is underneath the Y. So that's why your author depending on the textbook, sometimes they'll say they have 2 standard forms. And in this case, the one that we're using, it says that the A is always greater than B. So that's why we will have 2 standard forms for an ellipse. What is the second standard form for an ellipse then? The second standard form for an ellipse belongs in part B. What do you think the difference is? What do you think the difference between part A and part B is? Well, let's find out. X minus 1 quantity squared. Oh, why am I rewriting it? Didn't mean to rewrite that. I meant to write the other standard form. What is our other standard form? X minus h quantity squared over what? A squared plus y minus k quantity squared over b squared is equal to 1. So that's another standard form of an ellipse. Once again, A is greater than B and B is greater than 0. And A, once again, tells you half the length of the major axis. Once again, do your best to get a hold of graph paper. Having graph paper certainly helps. So this time, the oval is what? The oval is more stretched out in the horizontal direction. First thing you want to do is locate your center. Find that little blue dot. Let's see, it's 1, comma, negative 1. There we go. Let's locate 1, negative 1, little blue dot. And now, we need to travel A. What is A in our case? A is actually 5. And what's B? B is 1. All right, we're going to travel 5 units to the right. 2, 3, 4, 5, 6. So at 6, negative 1, there's going to be a dot. 6, negative 1 is a dot. And we need to go what? 5 units to the left. So negative 1, negative 2, negative 3, negative 4. So what is that? Negative 4, negative 1. Label your endpoints of your major axis. Let's draw what? Let's draw our B units. Our B units are vertical this time. We're going to go 1 unit up from the blue star and 1 unit down from the blue star. And we could label those as well. I'm going to go ahead and write ordered pairs. We're going to have 1, comma 0, and then we're going to have 1, comma negative 2. Play connect the dots. And there's your oval. Ta-da! Once again, if you wanted to, you could see that the length of the major axis here is actually 10. And the length of the major axis in the first example was actually, let's see, double the A amount, which is 6. Okay? And there you go. That's how you graph an ellipse in standard form. And if you really like the graphs to be neat, label your x-y axes as well. Remember the graph first on your paper. Graph the ellipse. 9x squared plus 25y squared equals 225. The first thing you want to do is have the standard form of an ellipse memorized. Once you have it memorized, you're going to realize that you're either writing this over and over again, or you're practicing lots of homework problems so that it will eventually get ingrained into your brain, and you will remember how to graph an ellipse. And remember, there are two standard forms, right? You could have a under the x values, or you could have a's under the y values. So keep that in mind. It is possible. And remember, a is always greater than b, and b is greater than 0, and a greater than b helps you locate the length of the major axis. Now, this is almost in standard form. Over here, the key is get that to be 1, right? So how do we do that? Well, this is an equation, so we could balance the entire equation. And if you balance the entire equation, 225 is not 0, so we could divide the entire sides by 225. And now we're going to use common denominator. And we almost have this in standard form. Almost, right? How many quarters in it are in $2.25? Turns out there are 9 of them. So that'll be quarters. So we have x squared over 25. And then plus, how many quarters? Oh, I'm sorry. I didn't mean 25 of them. Please correct me. That doesn't make sense. Oh, wait. That does make sense. There are 9 quarters in $2.25. I was right the first time. Here we go. How many quarters in $2.95? It's 9. So that's 9 right there. Fairly convenient. Equals 1. So there's some invisible zeros in there. I usually don't write them, but if you need to, feel free to write them to make things very, very explicit. And to me, this is good enough. Some of you might even write, 3 squared? Some of you might even write 5 squared over here, if it helps you remember. There we go. So what's our center? Ooh, our center is our little blue dot. It's kind of like the blue dot in your Google Maps GPS system. Our little blue dot here is going to be the actual origin. And what is our A? A is going to be 5, and B is equal to 3. And that's going to tell us how to graph our major and minor axes of the ellipse. In this case, it's elongated horizontally, right? And how is it elongated? Well, A is 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. And of course, if you have graph paper, please take advantage and use it. Makes things a lot easier. 1, 2, 3, 1, 2, 3, going down. And it luckily, everything's going to be labeled. Oops, did not mean to play a disappearing act there. I meant to plot a red dot this time. Red dot here, red dot here, red dot here, red dot here. Play connect the dots. So here's an oval, or an ellipse. It also looks like a football, right? You've probably seen many objects that look like ellipse. Looks like an ellipse. Some of you may have heard of Stewie's head. Stewie's head sort of looks like an ellipse. Yeah. Oopsie. Do the best you can. Try to round that up a little bit. And there's an oval right there. It's always nice to graph, or label, I should say, some of the endpoints. It'd be very, very clear. It's crystal clear. And what do we have here? 0, -3. And so there you go. There's your graph. Show work. Make sure you get it in standard form. Graphing an ellipse and its equation in general form. Well, that doesn't seem to help us the graph, right? Because we need A's and B's to help us graph the ellipse. Really, this is the general form. When you have all your variables, your multivariable function here on the left, and it's equal to 0. So this is what they're calling general form. In order to graph this, we're going to complete or perform one of the most famous tricks in mathematics. It is called completing the square. And that's going to help us get this into standard form. So remember, there are two standard forms for an ellipse. You want to have these memorized, or by now definitely write them on a formula sheet that you use for your homework. That way you could see it, and then you practice rewriting it again and again and again and again and again, right? So it really, whoops, I didn't mean to write that. I meant to write the letter B this time, B. And so there are your two standard forms. It just really depends on which direction your major axis is located. Remember, in either case, A is greater than B, greater than 0. And A is half the length of the major axis. Let's go ahead and complete the square. So we want our x's together, and we want the coefficient in front of the x squared to be 1. And then we're going to leave a blank there. I'm actually going to write this in parentheses and leave a blank. I want to collect all my y's together, and we want our coefficient in front of the y squared to be 1. So I'm going to write it in black here. Y squared, what else do we got? Minus 2y, and then I'm going to leave a blank here. So we're going to focus on the red and the black, or inside those parentheses. Where do I put that subtract 23? I'm actually going to move it to the other side of the equation. So add 23 to both sides. And you're going to realize now it's on the other side of the equation. So equals 23. Now in order to complete the square, it doesn't matter if you have subtraction or addition, it doesn't matter. Either one. We could complete the square on either positions here. So there's our blank. And in order to put, what do we put in that blank? Well, you take beta and divide it by 2, and then you square it. So that goes in there. Same thing over here. What would you do to put, add, I should say. Add beta over 2 and then square it. It's really a two-step process. So first, do beta over 2. And then second, do beta over 2 squared. Why don't we perform that over here? Take your 4 divided by 2, you get 2. And now you square it. If you square it, you get a plus 4. That means I have to add 4 on the other side of the equation. Let's do it for the quantity in black, or the second set of parentheses here. Let's take the 2 divided by 2. We get 1. And then you square it. So to complete the square, you're going to put a plus 1 here. Now, you think you're going to put plus 1 on the other side. Not exactly. I'm going to tell you you're going to put a 9 here. Now, you have to watch very, very carefully. Why did I put a 9 on the other side of the equation? So remember, this is a parenthesis. These parentheses are mandatory. And the 9 gets distributed. The 9 gets distributed to the y squared. The 9 gets distributed to the negative 18. The 9 gets distributed to the negative 2y. And the 9 gets distributed to the 1. So I didn't really add 1 to the left-hand side of the equation. I actually added 9. So to balance the equation, I must add 9 to the right-hand side of the equation. Now we could react to this problem. You've done lots and lots of factoring problems in your life. And so you see that that is going to be x minus 2 quantities squared plus what? Plus a 9. And then this is another perfect square trinomial. That's why you completed the square, so that you could factor. And if you're wondering how do I get the 2 and the 1 so fast, well, you factored. You factored probably hundreds of problems, if not thousands. And then beta over 2 is right there, right? So notice beta over 2 is here. Beta over 2 is also here. Okay, so when you did the beta over 2 process in completing the square, it goes right there. What's on the right-hand side? It is equal to 13 plus 23, which is 36. Oh, what a pretty number. Now, 36 is not 0, so divide the entire sides by 36, and then use common denominator, and we get x minus 2 quantity squared over 6 squared, I guess. How about I write 6 squared? Just to make things look nicer. Plus what? Y minus 1 quantity squared over 2 squared is now equal to 1. And there you go. You have your standard form. Which way is the major axis going? Is it going vertical? Is it going vertically or is it going horizontally? And of course, you don't have to guess. You just got to remember how to graph this. How do you graph this? First, you want to put your center. Your center is actually in which quadrant? Quadrant 1, 2, 3, or 4? Let you think about that as I draw a set of axes. And let's identify the center. The center is 2, 1. So it's actually in quadrant 1. Quadrant 2, 1. And I'm going to put a little blue GPS dot here, or a little blue GPS star to symbolize the center of the ellipse. Now I need to go 6 units to the right. So 1, 2, 3, 4, 5, 6, and that's actually 8. And I'm going to put a little dot right there, and I'm going to label it 8, 1, a happy dot. Now I need to go 6 units to the left of that blue star as well. So 1, 2, 3, 4, 5, 6. And what is that? That's actually -4. And I'm going to put another happy dot right over here. I'm going to label that as well, -4, 1. So there are the endpoints of the major axis. I got to go 2 units up, 2 units up, 2 units down. And I need to label those endpoints of the minor axis as well. So we got 2, 3, and then over here we got 2, -1. Ah, beautiful. What makes this more beautiful? Connect the dots. Form that elliptical path. Form that elliptical graph. Oh, so pretty. And there you go. You've graphed an ellipse, given its equation in general form. More importantly, you perform one of the greatest tricks in all of mathematics, called completing the square. Let's circle some work here. Circle your graph definitely, but make sure you can actually show the work that will help you get your graph. Finding the foci of an ellipse, given its equation in general form. Find the foci of the ellipse. Now you gotta remember that the circle doesn't have a foci, or the circle doesn't really have a focus. Instead, it does have a center. And because it only has one center, there really isn't foci. However, if you think of an ellipse is oval. So it turns out the way the oval takes place, it depends on two foci. You could call them f sub 1 and f sub 2. You could label them that way. Why don't we find the foci of this ellipse? Keep in mind that you do need to know an equation or formula to help you find the foci. Remember, one of their standard forms of an ellipse could be this, and another standard form of an ellipse could be where the a squared is under the y values. Let me erase part of the board here. Another standard form could be this. But in either case, we have a greater than b, which is greater than 0. And the formula for the foci is c squared is equal to a squared minus b squared. So it's very, very important that for an ellipse, you remember that the major axis is related to the a value. So the a is greater than b, and that will help you remember to take a squared minus b squared. We want the larger number subtracting the smaller number. Well, I don't see any a's and b's over here. So what famous trick do you have to perform here to make it look like one of these standard forms? Remember, these are standard forms. The one over here is called the general form. We need to complete the square. Let's do it. 5. Ooh, x squared is already completed. What do you mean x squared is already completed? Well, of course, there it is. It's complete. Now, the only thing left are the 9s. I mean, not the 9s, but the y's. So let's take a 9 here. Let's factor out a 9 and see what's left. Y squared minus 8y. And let's leave a space to complete the square. And then I'm going to move, or I should say, I should balance the equation by doing that, right? Subtract 99 from both sides. And we get a negative 99 over here. Now, there's only one thing to complete. That is the y squared minus 8y in parentheses. So remember, to complete the square, you need y squared minus beta y. Take your beta, divide by 2. That's the first step. The second step is take your beta divided by 2 and then square it. Once you do this, put it right there. Put it right there. So take your 8 divided by 2, which is 4. 4 squared is 16. Let's, you think you added 16 to the left, but you really added what? You really added 144. So keep that in mind. You did this nice trick here of adding 144 to both sides. Now what's left? Let's find out. Oh, now it's an algebra problem, so you just react to it. And we get 144 minus 99. How much is that? We'll take off 100 and add 1. So if you take off 100, you get 44. And add 1, you get 45. 45. Oh, it's almost in standard form. Divide the entire size by 45. And we're going to use common denominator and reduce, right? X minus 0 quantity squared over 9 plus y minus 4 quantity squared over 5. Ooh, 5. Aha, equals 1. Some of you might want to use a squared. Why don't some of you might want to use 3 squared? How about that? 3 squared and square root of 5 squared. So here's 3 squared, here's square root of 5 squared. Dun, 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 dun. All right. We need to find C. Why do we need to find C? I'll show you in a moment. In this case, well, let's identify the major axis. The major axis is in the horizontal direction because notice A is what? A is 3 because 3 is more than B. B is only the square root of 5, which is 2 point something. So let's find C. So our foci is going to be lying vertically along the direction of the major axis. The major axis is this way. So according to that, our equation for the foci in this particular case, the foci can be given as what? Let's do the center, HK, but it's H plus or minus C, comma K. So there's really 2 of them. The foci is going to be H plus C, comma K, or what? H minus C, comma K. So our goal now is to find C, our C value. We could solve C squared equals A squared minus B squared. Let's solve for C squared. C squared is equal to A squared minus B squared. So we have 9, 3 squared minus B squared. So that's 4. C squared is now equal to 9 minus 5 is 4. C is equal to plus or minus 2. But C is greater than 0. So if C is greater than 0, then C is 2. Make sure you write all this. Make sure you write your algebra. You have to write this. Okay, you have to write this. You really should write this as well. Make sure you write that. Write. Express your evidence. You must write that. Must write that. I'll be looking for that. So C is really 2. Let's find our foci. Foci. What is our H? Remember, our H is 0, and our C is 2. So our foci has to be a 2, comma, and then what is our K? Our K is 4. There they are. There is our foci. I could certainly circle our final answer, but as usual, make sure you are showing lots of work. Show lots of work. That should be written down. Show lots of work there. This should be written down as well. And if it helps, I could write it right here. C squared is equal to what? A squared minus B squared. There. That makes things much cleaner.